Hi, my name is David Lyons, and I'm from Tulsa, Oklahoma. And I will be explaining the activation energy of a neuron. So, this graph here represents many things, one of which, starting here, is the excitatory signal or a stimulus going to a neuron, starting here. And that has to allow it to reach the threshold, which, once it reaches the threshold, allows the neuron to go up to about 40 millivolts and reach activation energy. And then after it reaches activation energy, it then lowers and goes what we call to a refractory period down here, in which represents the returning of the ions to their original positions. And then, following the refractory period, you go back to the same place in which we started at the resting potential. Now I'm going to explain this graph with a diagram over here, which represents the axon membrane. So, we will start with the excitatory signal, which we pointed out was over here at negative 70 millivolts, reaching the threshold, which starts going through here. The action potential moves, the energy moves along here, and as this rises, the sodium ions move out inside the axon, which then moves the positive ions in here, which, as we've seen, makes it positive and goes up to positive 40 millivolts from negative 70. And then following that, the lesser going down of that part of the graph, reaching to refractory period, is the potassium moving outside the axon, kind of stabilizing things in both regions, and this potential along here, this signal, keeps moving through. And you'd see other gates following this along the axon to pass on what would create a chain reaction in this direction. And then refractory period, as right here represented in the graph, and following this is when the ions return to their original positions, and then we go back to negative 70 millivolts of the resting potential. And this has been an explanation of the neuron. Cut!